Hello everyone, this is Lods Elisi once again. So for this video, I'm going to discuss, to give you examples or example problem about mesh analysis, So this is problem number 2, part 2 of my series, mesh analysis. So I'm going to draw the figure or problem number 2 for the mesh analysis. So this is the diagram. So assuming that I have this circuit with a voltage source of 100 volts, then so this is under the category of supermesh analysis. Okay, so I'm going to draw first the diagram. Right, so assuming I have a battery here, which is 2 volts, and then I have here a current source of 1 ampere. Okay, so let's put the given ohmic value. So let's just use 2 ohms, 4 ohms pa rin. 6 ohms, 8 ohms, 12, and then for example this is 20, and then this is 18 ohms. Okay, so for this problem, solve the voltage or Vx, solve the voltage Vx using, of course, mesh analysis. Okay, so as what I've said, first step is to identify, label mesh currents. So if this is your mesh 1, so this is your mesh current I1. So if this is your mesh 2, so this is mesh current I2. And then if this is your mesh 3, mesh current I sub 3. So we solve for the equation for this mesh 1, So we can have the KVL. So solving for the equation, so at mesh 1, so in my first video, I told you, if you are inside a mesh current, or if you are inside mesh 1, so voltage first, so negative, positive, from negative, this one, it goes to positive because the loop is clockwise. So we label this one as positive. Sinabi ko na ito sa last time, positive. Positive 100 volts. It is always equal, So I'll just use the other color, para mas maganda tingnan, So positive 100 is equal to, so mesh I1. You sum up all resistor inside mesh 1. So yung resistor inside mesh 1 is 1, 2 ohms, 6, and 4. So you write everything, You add that 3 value. So 2 plus 6 plus 4. Okay, then the 6 ohm resistor is opposing to the other side, I am inside mesh 1, so since it is opposing to the other side of the mesh, then you subtract here 6I sub 2 because in that side is facing mesh 2. Then you solve the equation. So if you sum up 6 plus 2, 6 plus 4, then this is more or less 12, no? 12, I1, plus or minus 6I sub 2 is equal to 100 volts. So assuming, guys, this is your mesh current, or this is your equation 1. Okay. So refer to mesh 2 at mesh 2. Oh, no. We cannot get for the mesh 2 because we have a current source here, no? So always remember, no, the condition or mesh. When can we say that there is a super mesh? Or when can we say that super mesh happens? Super mesh happens when there is a current source. Now there is a current source between two mesh currents. So this is between mesh 2 and mesh 3. So saan dito banda? Ang ibig kong sabihin is 1. I have here a current source between two mesh current I2 and I sub 3. So we cannot have the KVL in mesh 2 alone, considering there is a current source. So what are we going to do? So we can get for the supermesh equation across this loop, and then after that one, we can also solve for the third equation, the constraint, no? Constraint equation. So how to solve for the constraint equation? So solving for the constraint equation. So of course, no, I am referring to mesh 2 and 3, no? Mesh 2 and mesh 3. So to solve for the mesh constraint equation, so remember the Cañete's principle again, no? This is I would like to share my techniques, no? Cañete's principle. So if I have a current source here downward, if the direction of the current is downward, then I have here the mesh current, no? I sub, basically in that example, I2, no? I2 now, I3. This is I3. So it is just like KCL, no? But for easy memorization, apply na lang Cañete's principle. If the direction is downward, so assuming this is your I sub x, so your Ix should be I mesh to the left, or the mesh current to the left minus I mesh to the right. So what if, sir, yung direction of the current source is upward? So baliktad, no? Nasa itaas yung direction ng current. So with this, so assuming pa rin Ix ito, tapos this is your mesh I3, and then this is your mesh current I2. So by applying again Cañete's principle, if upward, Ix is I mesh to the right minus I mesh current to the left. So pag downward, left minus right. Pag upward direction the current, left or right minus left. So basically for this given, so i-apply natin, no? Since yung direction niya is downward, so Cañete's principle, left minus right. So therefore, 1 ampere is equal to I sub 2 minus I sub 3. So this is my equation 2. Okay. So, lacking one equation, no? Kulang na lang tayo ng isang equation para ma-solve na natin yung I1, 2, and I3. So, we solve for the third equation by applying this loop, no? This one. Okay? So, this is how to apply, no? So, remember this one, ha? The technique in how to solve for the supermesh equation. So, solving for the supermesh equation. So, refer pa rin sa mesh 2 and mesh 3. So, this is how to do it, ha? So, first is you refer to mesh 1. I mean, refer to mesh 2. So, you refer first here, no? You refer to mesh 2. So, is there a voltage in mesh 2? Wala. Walang voltage sa mesh 2, right? So, you just put here 0. Or you can leave it as empty. Wala. Wala kang ilagay dyan. Next is you refer to mesh 3. So, mesh 3 na naman. Is there a voltage source? Yes, there is a 2-volt source. So, same sa simple mesh, it enters at positive, it leaves to negative. So, based on our clockwise direction, no, ang loop natin is clockwise. So, we put here negative 2. No, negative 2. So, it is just like combining, no, mesh 2 and mesh 3. So, all the voltages already combined, then equal na naman ulit. So, in the left side, you sum up all the voltage. On the right side, the individual voltage, the IR. So, in this side, you refer again to mesh 2. So, sum up all the voltages. So, positive I sub 2. You sum up all the voltage at mesh 2. So, 8. This one, 8. Then, next is 12. Plus 12. And then 6 plus 6. Then, if there is a resistor opposing to the mesh 2, you subtract again. Since at mesh 2, there is a resistor 6 ohm opposing to mesh 1, so you subtract here 6I sub 1. Okay, very clear? Is it clear? So, this is your mesh 2. Then, lastly, you refer now at mesh 3, no? So, you sum up all the resistor inside. Positive, positive. So, plus I sub 3. So, you sum up all the resistor inside I sub 3. So, the resistor present at mesh 3 are 20 and 18. So, i-sum up mo yung 20 plus 18. Since there is no resistor opposing, so walang nag-oppose kasi current source. But if there is a resistor, a loop here or a mesh here, so you can subtract I4. But since wala namang since only 3 loop or 3 mesh current, so there is no opposing, so wala kang ilagay dito. But you can put here 0 or minus 0 or wala na lang. So, if you notice, for this part, this one, this is your mesh 2. And then this is your mesh 3. Same with voltage, no? Mesh 2, then this is mesh 3. So, it is just like combining the two mesh. And after this one, you solve mathematically. So, negative 2. Then, this is 26 I sub 2 minus 6I1 plus 38 I sub 3. So, you just do it algebraically. So, negative 6I1 plus 26I2 plus 38 I sub 3 is equal to negative 2. So this is your equation 3. So finally, solving for the I1. So solve for the I1, I2, and I sub 3. So by applying calculator. So may borrow first the I1, 2, and 3. Yan. Okay. Huwag kayong maingay ha. Mag-record dito. Okay. Solving for the unknown parameters to equation 2. So solve 12, negative 6, 0, 100. 0, 1, negative 1, 1. Tapos negative 6, 26, and 38. Balik ha. 6, 26, 38, and then negative 2. Check ko muna ha. Bago ko i-finalize dyan. Right. 12, negative 6, 0, 100. 1, negative 1. 0, 1, negative 1, 1. Tapos negative 6, 26, 38, and negative 2. So therefore, 1654 over 183. Then for the I2 is 86 over 61. And finally, 25 over 61 ampere, no? These are all currents, no? I1, 2, and 3. So, if wala tayong na-miss dito na pag-add o subtract, so we solve now for the what is asked in the problem. So, the problem is asking for the voltage Vx. So, saan ba dito yung Vx niya? So, for example, the Vx I'm referring to here. For this side, no? For example, Vx here. Positive and negative. So, across the 6 ohms. So, to solve for the voltage Vx, maraming mga challenges po. Okay, so to solve for the Vx, we need first to solve for the current. So we can have, since the assumption is positive to negative by conventional current, so current must be in downward. And then applying Cañete's principle, di ba? Pag sinabing downward, it should be left minus right. So more or less, the current at 6 ohms should be I mesh to the left. I1 minus I sub 2 because downward man minus left or left minus right. So if we try to solve, basically the voltage Vx di is simply equal to I1 minus I2, IR man na siya, di ba? IR. Then you multiply the resistor 6. Okay. Alright. So more or less, what is I1? 1654 over 183 over 183 minus 86 over 61 times 6. So, try to solve it ha. Check nyo yung value. So, 1654 over 183 minus 86 over 61. Multiply by 6. Then, this is basically, the voltage Vx is more or less, pila? Magkano? Ilan? Total. 2,792 over 61. Approximately equal to, in decimal, 45.3. 77 volts. So, this is the final answer. So, ito yung final answer ha. The problem is asking for the voltage Vx, this one. Voltage Vx. So, check muna natin ha. Once again, baka namali tayo, no? So, check ko muna. Okay. Well, negative 6, 0, 100. 0, 1, negative 1, 1. Tapos, negative 6, 26. Tapos, 38, negative 2. 1654. Okay. So, this is the final answer, guys, no? So, this is correct. The answer is 45.77 voltage. Volt. 45.77 volts. Okay. Thank you. And I hope nakatulong yung sample problem ko. So, always remember, supermesh happens when there is a current source between two mesh currents. Remember Cañete's principle, if the direction of in solving for the constraint, if the direction is downward, I mesh left minus right. If the direction of the current source is upward, I mesh right minus left. Stay tuned, no? Follow, subscribe, Larry Angelo Cañete. Thank you so much.